Welcome to The Explainer. Today, we're taking a deeply analytical look at a massive, modern engineering challenge that honestly just gets completely lost in the noise of global news. We are going to strip away the rhetoric and look strictly at the numbers, the math, and the physical reality of naval defense. And hey, before we decode today's complex topic, do your job and hit that subscribe button for Conflict Explained to keep getting these deep dive analyses.
We're starting with this pretty dramatic claim made recently by Iranian state media regarding two massive U.S. Navy vessels. Now, statements like this immediately generate a massive wave of headlines, right? But our goal here is to look past the propaganda and dig right into the cold, hard math. Because when you're talking about targeting a U.S. carrier strike group, you are looking at the most heavily defended moving fortress on Earth.
Okay, let's dive into this by understanding that striking a carrier strike group isn't just pointing and shooting. It is a profound physics problem. To actually put a weapon on the deck of a ship like the USS Abraham Lincoln, an adversary has to solve a highly complex set of mathematical and engineering hurdles all at the exact same time. It's not just about having a missile. It's about mastering real-time kinematics. To really grasp how this works, we're going to peel this onion layer by layer. We'll look at 1. Inside the defense bubble, 2. The moving target problem, 3. The math of saturation, and 4. Kinetic threats versus signals.
Let's move right to our first gate, inside the defense bubble.
See, the ship itself isn't the defense. The defense is this massive integrated organism. An adversary isn't aiming at a single hull. They're aiming at an impenetrable bubble of sensors and weapons. The 100,000-ton Lincoln doesn't sail alone. It sits right at the center of a constellation of 9 integrated warships and around 75 combat aircraft. This strike group possesses layered sensors that actually outperform the entire national radar networks of most countries. Which means a missile must survive 4 completely different physics problems simultaneously just to reach the hull. Look at that outer layer. The SM-6 can intercept an incoming threat from over 130 nautical miles away. If a missile somehow survives that, it faces the SM-2 at 90 miles, then the highly maneuverable ESM at 27 miles, and finally, if anything leaks through all of that, it meets the autonomous Phalanx Gatling gun firing 4,500 rounds a minute. You literally have to run an impossible gauntlet.
But what about the other ship mentioned in that claim, the USS Tripoli? It's designated as an amphibious assault ship, so a lot of people mistakenly assume it's just a soft transport target. In reality, the Tripoli is a 45,000-ton floating airfield carrying 20 F-35B stealth fighters. That is more fifth-generation combat aircraft than most entire nations possess, and it's operating under the exact same Aegis destroyer protection as the Lincoln.
Now let's jump to Gate 2, the moving target problem. Having a weapon that can travel the distance is completely useless if you don't know exactly where the target is going to be when it arrives. 5 nautical miles. That is the immense distance a carrier moving at 30 knots will unpredictably displace during the brief 8 to 10-minute flight time of a Mach 3 ballistic missile. By the time that missile reaches the exact coordinates of where the ship was, the ship is 5 miles away, and the missile's radar cone is way too narrow to find it. To close that massive 5-mile gap, the missile requires an unbroken nervous system of intelligence, surveillance, and reconnaissance data. You have to find the ship in real time, feed that telemetry through a secure command and control network, and then provide continuous mid-course updates to the missile while it's in flight. If any single step in this chain fails, the missile just arrives at a patch of empty ocean.
But here is the reality check. After 38 days of Operation Epic Fury, this vital targeting chain is objectively broken. Over 600 strike packages targeted coastal radars, maritime surveillance drones were grounded, and over 2,000 command and control nodes were completely destroyed. Without that infrastructure, any launched missile is flying entirely blind.
Assuming that targeting chain somehow miraculously survives, we hit Gate 3, the math of saturation.
Overcoming an Aegis system requires saturation. Since the probability of a single missile penetrating all 4 defensive layers is incredibly low, you have to launch enough simultaneous weapons from multiple vectors to completely overwhelm the system. You basically have to coordinate dozens of missiles attacking at the exact same second just to guarantee a single hit.
And this is where the math becomes an absolute roadblock. Think about this drop in inventory. Estimates place Iran's ballistic missile inventory pre-Epic Fury at roughly 3,000. Now, it's down to about 1,000. That inventory has been slashed by more than half, with production infrastructure 85 to 90% destroyed.
Compound that depleted inventory with some major logistical nightmares. The most widely available anti-ship ballistic missile they have, the College Fars, only has a 160 nautical mile range, meaning it physically cannot reach the Arabian Sea. The longer-range Zulfiqar Basir could theoretically reach, but its launch infrastructure has been systematically targeted. The surviving mobile launchers are under continuous U.S. surveillance, and launch rates have dropped over 90%. Coordinating a massive, simultaneous launch is just physically impossible right now.
Which brings us to our final section, and honestly, the most interesting part. The twist: kinetic threats versus signals.
So, we've established the physical strike is impossible. The attack chain is broken, the inventory isn't there, the ships are moving fortresses. They know the math just as well as we do. So why make the announcement to diplomatic channels in the first place? What happens when the weapon isn't a missile, but a signal? See, there's a fundamental engineering asymmetry here. The Aegis system is perfectly engineered to intercept physical objects, things with a ballistic arc and a radar cross-section. But it has absolutely zero layers designed to stop a propagandistic signal traveling at the speed of information. The headline isn't a physical object, so it entirely bypasses that physical defense bubble.
I really want to leave you with this profound asymmetry to think about. While physics guarantees the hull of the ship is completely safe from kinetic missiles, the combat system itself was never built to intercept headlines. When you design the ultimate defense against physical threats, what does it mean when the threat changes domains entirely? Thanks for exploring this with me today. Keep asking those hard questions, and I'll catch you in the next explainer.